All right, so we're continuing with the program. So our next speaker is Nicholas Oji, who will be talking about benchmarking, big data, and automating such benchmarking, which is actually a great topic and kind of dovetails into some of the presentations on BigTalk. So I hope maybe some of you will consider adding this stuff to the BigTalk. So with that, Nicholas, the stage is yours.
Okay, thank you very much. Yes, as you said, this is a good continuation for the previous talk. It's a bit different on some way, but we tackled on the same kind of problems when trying to set up and configure big data systems. I'm from the Barcelona Supercomputing System and Technical University of Catalonia, there in Barcelona. And yes, and we have been benchmarking Hadoop and the ecosystem for over 2 years continuously. And this talk is a bit about the tools that we have released, but that were designed for our daily usage. We found many things trying to benchmark Hadoop into HPC systems, cloud, and even low-power devices, ARM architectures. So I'm going to briefly go over those. So the agenda, I'm briefly going to introduce the problematic. Why do we need Hadoop benchmarking and so much? The Aloja project, this is the open source project that we're working on. A little bit on benchmarking, according to time we have, and I'm going to go through the results. And briefly over the predictive analytics and modeling capabilities that we have in the framework to extract performance knowledge. And the idea with this is to automate the whole benchmarking process even further. Okay, so let's start with Hadoop. Probably most of you know Hadoop. Hadoop was designed to scale almost linearly to solve the complex data problem, different kinds of data structures, unstructured, non-structured, we throw all the data in. Its application level reliability, so it can run on commodity hardware. But one of the things I want to remark that I think it got into Hadoop popularity is the MapReduce programming model. It simplifies a lot the programming model from previous programming paradigms such as MPI or QDA that are used typically in HPC systems. So for the data analyst, MapReduce has been very helpful. They need to worry on writing a map and reduce function, or similar for Spark on other systems. And the complexity of concurrency, locking, replication, reliability is hidden from the data analyst. This is fine. The Hadoop operates as a black box. But if you're a system administrator, if you're running the system, this can be finding actually what's going on beneath and trying to optimize, get the most out of the hardware can be really hard. This is even further with Yarn. Yarn simplifies and logically abstracts system resources further. But if you really want to extract performance from your hardware, it's not that simple. Okay. Okay, and Hadoop was designed to be highly scalable, but not a high-performance solution. If you read the original HDFS papers, they're talking about reliability, scaling, linear scaling, but not high performance. In Hadoop, to really get the performance out, you need to design the topology of the cluster. You need to select how you will arrange the disks, the mount points. For example, you need to put disk in a JBOD kind of fashion, in an array, not in a RAID controller to get more performance. You need to set up the OS, Hadoop configuration, and all of this requires a lot of iterative fine-tuning of configuration parameters in all of the system, and it's very time-consuming. And so it requires extensive benchmarking. Part of the reason for this is that Hadoop by itself has over 100 configuration parameters. Some of these parameters can be more simple, like the number of mappers that can run per host in parallel, or containers. Usually you have some rules of thumb in books or in blogs. Tells you, okay, put one container per core you have in your system, and things like that. But other parameters are more obscure and might be interrelated with others and dependent on your hardware, like percentages for spilling buffers to the disk. And another part is that the default values of Hadoop here, I have them on the default values on Hadoop are not usually the best performing values. For that you need to do benchmarking, but also in some blocks you can find that, for example, you store megabytes, the default value was 100, but 300 might, in some blocks, say might work better. And the same for other parameters. This is not only for Hadoop, but also happens in the rest of the stack. And you don't only have to tune the systems, you also have to tune from the physical level to the application level. So there's a big stack for tuning. So how do I set my system? There are too many options. Should I move to the cloud? Should I have my system on-premise? What distribution of Hadoop should I use? Should I follow product claims? One of the problems in the ecosystem right now is that there's very little transparency. Every new enterprise version of Hadoop that comes out from vendors is faster than the others. Very difficult to actually verify this and make sure that you're getting the right thing. There's no one-fit-all solution. It all depends on your data, your software, and your application and your budget. And what about new hardware like SSDs, InfiniBand networking that you find on HPC systems, pretty much only on HPC systems? Should I use them for Hadoop? Should I invest in this new hardware? These are all questions that if you want to set up a new cluster, optimize or migrate, you might be asking yourself, even if to put it in the cloud into platform as a service, for example. So that's a little bit the background for our project. Our project is called Aloja, and it's an open project, and the idea is to improve the cost effectiveness of the data system. The idea is to take into account costs and performance of the systems and be able to get the most out of your hardware to make them more efficient. And through these 2 years pretty much that we have been benchmarking Hadoop, we have built some tools, mainly 3 main components, with data benchmarking tools, where we have scripts to deploy on servers, either on cloud or on premise, configure Hadoop for benchmarking, put all the binaries that you need, start benchmarking, collect results, gather telemetry and performance metrics, and pack everything into a table. And then we have the online repository. We're not only making the source open, but also the performance data. So all of the performance benchmark, all the performance data is up on our website. It can be browsed and you can look at all of the logs. And on top of that, no one wants to be looking at thousands of logs with thousands of lines. You probably did this at least one time or another. We're adding analytics tools on top of this big corpus of data. And I'm going to show some results later. We have over 50,000 runs of benchmarks. This is a large, I think, a large number. We're also doing a lot of machine learning. So we have a big data problem within the project, and we're trying to use different big data tools and analysis to get performance knowledge. And we do some different hardware configuration. We have over 100 different configurations tested. And we want to broaden the community. We're working with some universities, and some companies are already using either the results or a private installation of the framework. Okay, so this is the main workflow that I would like for it to have. It's mostly done. So the first thing when benchmarking, you need to decide where you're going to execute things and what, of course. The first thing is defining a cluster. This might be, if you only have one cluster, it might be silly to say, okay, I just have one cluster, but in the cloud you could have different sizes of clusters. You can pick different virtual machines. For example, in Microsoft Azure, you could, last time I checked, there were over 32 different virtual machines you could select to execute Hadoop. Which one is better? You might need to benchmark that. Here you can select the number of nodes, the operating system or distribution you want. And then once you have that, for example, in our case, we have a 20-node cluster. And what we do is sometimes we run with 16 data nodes. Sometimes we run in parallel 2 of 8. And we do different sizes of cluster depending if we want to iterate configuration faster or we're testing scalability. So The first thing is logical definition of what is a cluster, what disks I'm going to be testing, because even though your cluster might have 6 disks, I just want to benchmark with 1 or with 2 or to see the scalability of this, how they have good performance. Then is the execution plan, what benchmarks I'm going to run, what configurations I want to iterate on. This part takes care of the deployment and actually running the benchmarks. And from that, you get the benchmark has already run, you have all the performance traces, and you need to import them. So it's a lot of log parsing, and we put everything into a relational database. We call the historical repository, and from that you can do your normal performance analysis. And we're working with researchers on predictive analytics and automatic knowledge discovery. Okay, so some of the challenges we were facing 2 years back when we were starting, we wanted to test on different architectures, and what happened was that for some HPC systems we had to access the system with different users. We have different access, access levels. In some systems we got a root user, especially in cloud systems. With a root user you can do everything, and the cloud you can destroy, start virtual machines. And on HPC systems that you borrow, you cannot install in packages and pretty much do whatever you want. You need to play well with others, and when you're benchmarking, when you're done with it, leave no traces on the system, so you need to uninstall everything, unpack everything. So we found that some tools that were working for on-premise hardware wasn't working for the cloud. You need deployment tools. Also, platform as a service, it's a different paradigm. You don't install Hadoop, you just run your jobs there. And of course, we have different versions of softwares. And we found many problems. Most of the tools, open source tools for Hadoop and deployment and configuration are sold for production environments. When you're benchmarking, you're not running something continuously. Also, when doing performance analysis, you're interested in comparing things, not if the system is running fine at a particular moment. We started working a lot with Puppet, I think it was mentioned before. We dropped using Puppet some time ago because benchmarking was really slowing us down. Not only deployment times, but also the learning curve for other people using the platform. And another thing that we were lacking was a development environment. I come from a development background, and in big data, you pretty much to test things, you need a cluster. And this was very problematic 2 years ago. So we spent a lot of time building background boxes, working with Docker to try to be able to run everything from a local environment. So what we end up doing, like everyone does, is a kind of Frankenstein solution, like this elephant. So it's a custom implementation, but we basically have an abstraction layer on top of very simple and known components, and we want to give it like a same interface to access either HPC clusters or cloud services. Okay, the repository, as I was saying, is 3 main components. What I want to remark is that the big data benchmarking part is only bash scripts. We call the typical Unix tools, and for the cloud we use each cloud provider's binaries. Bash or shell scripting is what you generally use when doing benchmarking anyway. For the web part, we have the typical LAMP, but with Nginx. We keep everything right now on MySQL, and for analytics, we use R, SQL for grouping, and JavaScript for interactiveness and the web. To clone the repository, to get a sample data set and everything working is just cloning the repo. By background app, you should download everything. But you could also run a development cluster on your local environment if you want. Go to results. We have some commands to connect. This is very useful for me. Like I use connect cluster name, and it will connect to me if it's cloud or an HPC cluster. It will select the user automatically. Everything in configuration files. If I need an SSH gateway, I can have that pre-configured. So I do connect cluster name, and then well, it's printed, the whole SSH that connects, but you don't have to be remembering host names, IP addresses, users, and things. It's really useful when you have over 10 clusters running in parallel. We have the deployment scripts, and also queuing. When you're submitting many benchmarks, we queue them to track if they fail or not. But some support for these cloud providers, OpenStack is supported, and some platform as a service. And to run benchmarks, let's start the script. It's just a script called runbench. This is my machine. Well, the resolution is. This is Workcam. What it does, the script, is it will start testing the cluster, test the connectivity. If it needs to download, we can probably pause this. I'll just leave it like that. It will download Hadoop binary if it's necessary, set up everything, start, well, this is what you typically see when starting Hadoop, checking if the ports are open, starting the telemetry, and it will start running, in this case, workouts that I had set up for it. The results are online on our website. There you can browse all of the different executions, see the performance log, but I'm going to pass through some more advanced results. One of the things we do is speed up charts, normalized graphics of performance. You can select which category, like I want to see what's the impact of changing the number of containers, number of mappers in parallel and things like this. Here we have two charts. Here we're testing disk and network in a cluster. Rotational disk plus Ethernet. Higher is better here. Each color is a different benchmark. Here we added SSDs with Ethernet networking. We see speed ups for some of the benchmarks. Then we tested rotational disk with InfiniBand, and we see that there is not much improvement from running it with regular Ethernet. So if you have InfiniBand to really take advantage of it, you need to have a fast disk system. This is SSDs and InfiniBand. And here we measure how much performance improvement you will get by, for example, adding more expensive hardware. InfiniBand with rotational was not performing well, and with SSDs, but this is not the same for all benchmarks. And in the other chart here is similar, but in the cloud. The first is executing with HDFS on a local disk, which is faster, but on the cloud, usually local disk is for scratch or temporary. You put the files on S3, blob storage, whatever. So this is with one remote volume. You see that the performance decreases significantly. Here we added a second one. We got a little bit more performance, but with the third, we didn't get more speed up increase. We got more capacity in the system, but no more speed up. The last three bars are 1, 2, and 3 remotes, but having the Hadoop temp directory in the local disk. So you can use the local disk for temp files and get some performance speed up. You can see more samples on the side. This is another one, but taking costs into account. Here I have dollars, cost on the y-axis, and execution time. So 0.00 is the best. These are, each bubble is a different cluster of different VM flavors. So we see here that the fastest one is the performance 230, but it's also more expensive than the performance 18, which is slower. And these three others, pretty much I can discard. I see these are not the fastest and are not the cheapest virtual machines to run Hadoop on. Even though these ones were called IO130, IO115, these are IO optimized virtual machines, but probably for relational databases. In the case of Hadoop, the configurations we tested, we didn't get this. But you get this information also in a tabular format. So the most recommended cluster would be this one. This would be the most cost effective. A run of TerraSort of 100 gigas will cost 30 cents and will take about 400 seconds. But the fastest, which is the fourth here recommended, would be this one, and it would take almost 300 seconds, but the execution cost will be 72 cents. And this is some of the comparisons we're making. Another one is scalability. Here we're changing the x-axis to number of nodes from 2 to 32. The solid curve is execution time. So as we add more nodes, the faster it goes. But we found that there is a point of diminishing returns here. This dashed lines is costs. And in this particular cluster example, after 8 nodes, you could gain a little bit more performance, but your cost will go higher. This is for cloud. And we also have some predictive analytic tools. I just want to go briefly over them. You can ask me a bit more later. We do the typical 3-step learning process for machine learning. We split all the data set into training, validation, and test data set. And with that, we model Hadoop with different classifiers. I will give the references of the different classifiers we use. And the use cases we give to this is first anomaly detection. We have over 50,000 runs, and we don't know which ones fail and which ones not. Which one are outliers or not, which one need manual attention. The first use case we give is outlier detection. Here we see the ones in red and orange are the ones that mark as outliers. We use it to predict what would be the best configuration for a given hardware, even though we haven't benchmarked that. Guided benchmarking. So I have a new cluster, I need to do benchmark. I ask the system which is the configuration I should run next, and next, and next. So to automate the configuration iteration further. And we're working a lot on knowledge discovery. Okay, so the idea is here that we don't have to be looking at the logs and all of the performance of all of the runs, but to automate this further, to get the insights right from the model. This is work in progress, of course. Just to conclude, we've been benchmarking different systems for over 2 years. Each system has its own peculiarities. Either users, sometimes you have different versions of the software installed, even different bash versions might make. One of the reasons we use bash is very portable, but you can find that some systems that you get to benchmark on have a bash 3, a very old version, and then some things are not supported. Different access levels, different packages, different versions, this all impact on benchmarking, and it gives you some hard work. And they all fail one way or the other, but you need to program for failure. You need to be aware of if a benchmark fails, make sure you close all the ports, all the telemetry, so next time you run, things might run. Okay? I like benchmarking. Benchmarking is fun. If you don't like it, at least it will save you some money if you have your own cluster, or it will allow you to scale even further. If you don't want to run the benchmark yourselves, you can start by looking at the results we have on our website. One of the things we want to bring is a little bit more transparency into the big data ecosystem, having the logs and everything reproducible from benchmarks. So we have scripts. We're working on version 3 of the platform. You're invited to participate. Please come look at me if you have more questions. I will leave some more references on the slides of papers and other presentations from benchmarking. Just to finish, this is our supercomputer in Barcelona, called Mare Nostrum. If you like architecture, either building architecture or computer architecture, you might like this. It's a tourist attraction in town. It's inside an old chapel. So if you're around town, come to visit us. We can talk about some different systems. That would be all. Thanks for your attention.
So any questions for Nicholas?
Yeah,
you go.
You said that you previously used Puppet.
Yes.
What are you using now?
Just pure bash. Yes. I'm very happy with it.
But is it easy to switch out to something else?
Well, the problem with Puppet was that if you run a production environment, it's fine. Because you have everything installed already. But we were deploying clusters very frequently, and for example, installing modules was very, very slow, and sometimes my SQL module will fail to install for some reason, or some other module. Also, it was slowing deployment down. Also, when working with somebody new, joined the team or was working with it, you have to learn Puppet. And the being not sequential, the execution, it was very confusing for some people. And in the end, we removed it. In the end, you're writing pretty much similar to Bash script in Puppet, so we just removed that later on. We can do that like that for a year. I'm not against Puppet.
Yeah,
How easy is it to adapt to measure benchmark value?
Yes. So basically, it's Bash script. You tell it if you have a confirmation for your script, and then you define a run function where this is a sleep example, where you tell it what command to execute. There are some more complex examples, but you pretty much copy a file and then modify it with your script. That's the idea.
any,
You said that you use InfiniBand for Hadoop as well, but you're leveraging the low-hanging fruit like IPO or IB, or is it native InfiniBand?
No, IPO or IB. Yes, well, on documentation we make it clear.
It's not possible to use native IB verbs, right?
It is, there are some modules. Mellanox, InfiniBand provider, provides some modules for it, for UDMA, I think it's called, and there's a university that also provides some modules for Hadoop, but it's external thing.
any more questions?
What granularity of measurements do you have to go down to the container and manager level?
Like a process, per process. Yes and no. We don't enable it by default per process metrics. We do parse the Hadoop logs and get there each mapper and user, the state and the amount of data that it has processed at that point in time. But we don't go per process by default. It's too much longer.
So you have the detailed stats by
By what?
You have the detailed stats from this for the exact node, or do you measure it like a whole cluster?
No, per node.
What scenario do you use?
Scenario? What?
Yeah, technological scenarios.
Okay, so we don't develop the benchmarks themselves, we mainly use HighBench, which is a benchmark suite. It has Terraform work counts, some machine learning examples, some natural language processing. We use TPCH, standard SQL, for data warehouse on Hive. Big Bench, which is a benchmark that is specifically for big data systems based on TPCH. And we're working with a spec, I didn't mention that, with a spec standardization body on benchmarks to build a new big data benchmark.
And with that, we're out of time, so thank you so much.